excited that you have joined in and you are watching this lesson. Last time we were looking at variation, and we started looking at one of the components of variation, and that is direct variation. Okay, so I gave you an example, and I left one example which we did not finish. Okay, so that you can also finish, that I see how you are also performing. Okay, so the question was that given that y varies directly with x and y is equal to 8 when x is equal to 6. First question was to find the constant of variation. Okay, and we solved that one. We say the constant of variation was, the k was 4/3. That's what we actually solved. Then the second one was to find y when x is equal to 3. Okay, and we also solved that one. So if you have not watched the previous video, I'm requesting you guys to watch the previous video so that you see the question. And the last one that we didn't solve was to find the value of x when y is equal to 24. Okay, so our equation is equal to y is equal to kx for direct variation. And what we are supposed to do now is to find the value of x when y is equal to 24. So what we are going to do is we're going to place 24 there equals to k, which is 4/3, 4/3, then x. Okay, so in this case now we are going to do what? To find the reciprocal or the multiplicative inverse of what? Of 4/3. The number such that when you multiply it by 4/3, we are going to get what? 1. So that we remain with x, or make x the subject of the formula. So this can be written as x is equal to 24 times 3/4. And our x is equal to, this one cancels 1, this one goes there how many times? 6 times. So 6 times 3, we're going to have what? 18. We're going to have 18. So that is what we are supposed to do in the previous lesson. And if you had solved it like that, then that was it correct. Okay, so now what we are going to do today, we'll continue with our lesson of variation, and today we are going to look at inverse variation. Inverse variation. So what is inverse variation? When we talk about inverse variation, this is a kind of a variation or a type of variation whereby actually it's a relationship also. Remember, when we talk about the variation, we're talking about a relationship between two variables. So if in inverse variation, it's a type of a relationship such that as one variable is increasing, the other variable is what? Decreasing. Are we together? So it can be represented as simple Cartesian plane. Okay, so we have y and we have x. So the inverse, we have that arrangement there. So as one variable is increasing, the other variable is also what? Increasing. Are we together? Very good. So it can be represented by an equation y is equal to what? K over x. Y is equal to k over x. Are we together? Very good. So that is how you can represent it. So we can say that if we inverse, y is equal to k, okay, 1 over x, which is as I said, the k represents the constant of variation. Are we together? Very good. So let's look at an example how we can apply inverse variation. So an example could be, we can say example, okay, so example will be given that y varies inversely with x, okay, y is equal to 4 when x is equal to 7. Okay, given that y varies inversely with x and y is equal to 4 when x is equal to 7. Okay, so now the first question is to find the constant of variation. The first question is to find the constant of variation. So how do we find the constant of variation? Say find k. And what is k? The constant of variation. Okay, so how do you solve that one? Now our equation is y is equal to k over x. If you want, you can say k open bracket 1 over x. That's one and the same. Then we start now doing what? Plugging in what we're supposed to plug in. So I'm going to say, since we've been given y, our y is 4 and our x is 7. So we can say that what is our y? 4 is equal to, do we know k? No, that's what we are looking for, over 7. Okay, k over 7. So what do? We make k the subject of the formula by multiplying by the reciprocal of 7. Now this one is the same as 4 is equal to 1 over 7 times k. So for us to get rid of 1 over 7, we multiply it by what? By the reciprocal, and that is 7. So whatever we do to this side is also done at the other side. So this can be written as k is equal to what is 7 times 4, which is what? That is 7, 4 times 7. So our k is equal to 28. So our k is equal to 28. Are we together? Are we together? Very, very good. So what I'm going to do is, I'm going to give you 2 questions under this example that I want you to try and see how you can think. Are we together? Very good. So, the other question is B. Under that one is you are finding the equation. You are finding the equation for this situation. For this situation. Finding the equation for this situation in the form y is equal to k over x. That's all. And part C, the value of y. The value of y if x is equal to 6. So these are the 2 questions that I want you to attempt, and I want to see how you can think. Okay, so this has been your teacher Kaira, with inverse variation. See you in the next video where we'll be looking at joint variation. Thank you.